Assalamu alaikum, Sir Rehan, Halar Mustafa. Can you hear me?
Yeah, walaikum salam. I can hear you.
Sir, meanwhile, participant join the session. Shall we start our webinar or not?
I think we should wait for the participants for the next 10 minutes.
Can wait for participant. Uh, I try to share your screen. Can you please share your screen right now?
Okay, just give me 1 minute.
Sir, your mic is mute.
नहीं हो सकता कि मैं शेयर करूं और वो आ जाए इसके ऊपर.
Yes, sir. 1 minute, sir. Can you share your screen, sir?
Yeah, if you could stop your screen, I could share your moment.
I have to stop the share. Yes, sir. Now, please share.
Okay, just wait. Let me just have a slideshow. Share and then. Can you see that?
Yes, sir. I can see your screen. Participants have joined the session. Shall we start from?
I can't see the participants. Only one participant at the moment.
I think there are 7 participants are there. Some of are in waiting.
Some of them are in waiting. Get all of them in.
I think we start the session because time would be in introduction and recitation of Holy Quran. Then some of the participants would be join the session. So
Okay, just wait 1 minute and then we can start and then we can end the session at 12:45 inshallah. Can you hear me?
yes, sir.
Yeah, I'm saying to start session in 1 minute and then we can end the session at 12:45
Yes,
p.m.
sir.
inshallah.
Yes, sir. Definitely.
Or recording session also and get some snapshots for the session.
Yes, sir. We can take the snapshots and
All the medium instruction in English, or we can use both of that.
majority are fine with English, so you can continue in English.
Okay, fine.
Our webinar coordinator Haya Amir joined the session, so he will also record the backup as a backup, and we can also take some snaps for the session. Sir, can we start the session? Shall we start?
Just 1 minute. Just 1 minute. I think you can start the session.
Thank you. Assalamu alaikum to all faculty members, students, researchers, registered and professional engineers. I welcome all of you on behalf of CPD core team. I myself, Engineer Adil Khan, PB CPD coordinator, and Engineer Halal Mustafa, co-convener CPD activities, and Ms. Haya Amir, webinar coordinator. First, we start the session with a recitation of Holy Quran. So I request with all of you to please silent and listen carefully. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم إنا أعطيناك الكوثر فصل لربك وانحر إن شانئك هو الأبتر صدق الله العظيم. तर्जुमा बेशक ए नबी हमने तुम्हें कौसर अता किया तुम अपने रब की इबादत करो और कुर्बानी दो बेशक तुम्हारा दुश्मन हर खैर से महफूज रहे. Today, point 5 CPD webinar is on modern trends of thermodynamics in mechanical engineering. This CPD webinar is organized with the collaboration of Hamdard University, Main Campus Karachi, IIT Center Karachi, and Pakistan Engineering Council. For today's webinar, we have guest speaker, Engineer Rehan Khurshid, Assistant Professor and OB Coordinator, Mechanical Engineering Department, Hamdard University, Karachi. He done his BE in Mechanical Engineering from NED University, Karachi in 2009. Then he done his MSc in Energy Conversion and Management from Energy of Nottingham in 2013. Now comes to his working experience. He is an assistant professor and OB coordinator FEST in Mechanical Engineering Department since 2016. Before that, he served SAS Engineering Private Limited as mechanical engineer from 2014 to 2016, and before that, he served Atlas Honda Private Limited as management trainee from 2010 to 2011, and before that company, he served Procon Engineering Private Limited as quality assurance engineer from 2009 to 2010. So, without any wasting of time, I am requesting with Engineer Rehan Khurshid to sir, please start the session. Sir, over to you.
Thanks very much indeed, Adil, for the introduction. And let me just start the presentation. Assalamu alaikum wa rahmatullahi wa barakatuhu to all the participants. And this is point 5 CPD webinar as told by Adil. And the topic today, which I'm going to talk, is about the modern trends of thermodynamics in mechanical engineering. So in this presentation, I will give you that's a brief outline of the presentation. First, we'll talk about the importance of thermodynamics and some of the basic concepts we will study here, and then we will go for applications. And finally, we would see what are the modern applications here in this subject. Now, before starting that presentation, I would like to tell you about something about mechanical engineering, which from a common man perspective here. That's actually trying to highlight the importance of this subject. Now, the mechanical engineering, the heading which I gave here is limited concept. Is that because people always think about mechanical engineering like driving the cars, and in manufacturing and in industry and this aircraft and ships and these kind of things that they are interested to know. And for that reason, their knowledge is just limited to these type of devices, such as gear. Almost when we talk about engineering, we always see gears here. Okay, gears, pulleys, bearings, and shafts, and presses and machinery. These all concepts come in our mind, which is related to the mechanics. Mechanics, like if some academics here, they should know like mechanics means forces and motion and movement and velocity and circular motion and these type of things we are interested in. That's a general perspective come in my mind. But on the other side, if you just sit in your room where you're sitting at the moment, if you just imagine how this energies of light is coming from, and this electricity which I'm using the laptop is coming from, and that air conditioning which I'm sitting in enjoying comfort from, where this is coming from, and finally how the car is driving. That's the question that come in my mind, in a common person mind. And that thing provoke persons to come out of that mechanics here and think of something beyond that. So the point is that these applications come under the influence of power plant and like heating, ventilation, air conditioning. Okay, and further, if I would like to define mechanical engineering, it's actually based on design and manufacturing that always know. But the last part is thermal sciences. That's the point which almost people neglect here. No, that's a thermal science, and that we would like to highlight this issue at this point, that what kind of thermal energy is changing in your life. What's important is that, and how this is deeply involved in your life, that we must explore here. Now, this thermal science related to the branch which is known as thermodynamics. What thermodynamics do? Thermodynamics is actually composed of two words, which is known as thermos, which is actually Greek words. Both are Greek words, thermos, and the second one is dynamics. Thermal means the heat, and dynamics means the movement. That means what heat is being produced is actually being converted into dynamics. It's actually being converted to the work here. So that's a relationship between what energy and work is, and how we can relate, and how we can make applications and bring betterment in our life. So first, we will just quickly review of the energy. Energy, you always know that it's a physical energy which can bring a change. Energy can neither be created nor destroyed, but it can change in the forms. Okay, and we have different kinds of energy, like kinetic energy, which is by movement, and potential energy, which is by the height here. And there are lots of other energies as well, like sound energy, and like chemical energy, and like electromagnetic energy, X-rays, and nuclear one. How we can make that useful? That's the topic of thermodynamics. Okay, and now we talk about the energy, like we will also talk about the work. Work is actually a force which is causing the movement. Okay, now the forces which come in your mind is by the hand or by something rope. You're just putting a force in that. But how can heat is producing that work actually? That's the field study of thermodynamics and thermal sciences. So in this diagram, in this presentation, in this slide, you can see actually some of the heat is being produced here. We are not talking about how this heat is produced, like with the help of steam or with the help of chemical and everything. The suppose heat is producing, and that heat is being flown into our piston devices, and that actually producing a force on that piston. And that piston is trying to move this crank mechanism, and and after that crank, there is some other phenomena is attaching. Now, see that how this heat is actually forcing a piston to move. So that's a basic overview of the thermodynamics, which is actually showing the relationship between the work and energy. Okay, let me just proceed. And now what the subjects actually the thermodynamics is covering in mechanical engineering, and these are the subjects which actually thermodynamics is covering in mechanical engineering. If you go into deep in that, we have heat transfer, which is related to modes of heat transfer calculations, and then we have power plant engineering, that how we produce energy to produce for the electricity. And the last part, which is the most important one, is the refrigeration and air conditioning, like you enjoy comfort air in buildings, comfort in your homes. That's also related to refrigeration and air conditioning. Now, these are the major applications of thermodynamics, which mechanical engineer must know. It's in your homes, it's in automotive, it's in power sector, it's in construction industry as well. And most of that, you can also see this application in electrical and electronics as well here. How this is in electrical and electronics, we will see that it's something beyond that, electric circuits and electricity. Now, I would just briefly talk about some of the basic concepts before starting the application, that everyone must know the basic concepts of thermodynamics. I would like all the participants to take closely at these basic concepts. Now, as we said, thermodynamics is a theory of motion which is related to heat transfer and heat energy between the surrounding and the objects. Okay, like we have melting of the ice, like we have boiling processes, and secondly, we talk about the branch of thermodynamics. Thermodynamics is everywhere. Like we have classical thermodynamics, which is we are studying here. And then we have chemical thermodynamics, which is related to the chemical changes and how much energy we can extract from the chemicals. Then we talk about statistical thermodynamics, which is on the molecular basis. And finally, we have biological thermodynamics, which is actually what thermodynamics is playing a major role in your body structure, like in your body temperatures. And also for the plants and for the microorganisms, that how can their temperature change can bring the uh, change in state. Now, some of the home examples like boiling on your stove, a hot cup of tea analysis. And if you go for the practical examples, which is far large here, like internal combustion engines, like we use in car engines, the aircraft engines, and also refrigeration, air conditioning, and power plant, and also number of engineer. Like from your home to the big industry, thermodynamics is everywhere, and even in the atmosphere as well. So the first concept is about the basic law of thermodynamics. Basic law of thermodynamics, which you have known for the past many years, like which says energy can neither be created nor destroyed. Okay, that's everyone knows. But what exactly the first law of thermodynamics states us? The first law of thermodynamics states us is actually a statement which says first we talk about the symbols. Q is the heat supplied, U is the internal energy of the system, and W is the work done. Like it says, when you give a heat to a system, it gets split into two, like it starts to get work in two. The first part, the first work is that it will increase the internal energy of the system. And the second part is that it will do some work. That means, for example, if you make a system, like if you make a water in a jar or in a beaker, if you just heat that water, that heat would be transferred to that water, that system, and that system would be capable of two things, like increasing the internal energy, and the second part, which is our concern, which is most important, that how much work we can extract from that energy. That's the main part is. Okay, this is the first law of thermodynamics, which is applicable to almost all the systems. Like we have systems in boilers, we have chillers, and every experiment we use this first law of thermodynamics. Okay. Now, I will just briefly talk also about the water heating system that we have heating at our home, but we have never noticed what actually phenomena is being occurred. I would like to tell this phenomena with the help of a diagram, which is known as the TV diagram. Okay, let me just tell you here, we have many diagrams in thermodynamics, like temperature volume diagrams, pressure volume diagrams, temperature entropy diagrams, pressure enthalpy diagrams, and many more diagrams we here that we analyze in order to design our systems. So the reason for telling you this about the TV diagram is that these diagrams are mostly used in the power plant designing, in the boiler and in condenser. What happens when you take the water from the tap at your normal temperature, which is actually around 30 degrees centigrade, or the pressure is around 1 atmospheric pressure. Now, when you take the water, that water is known as compressed liquid. Okay. And for example, the pressure is around, I would say 1 atm. If you just start heating that temperature, if you start heating that water, the first what would happen at the same pressure, it will start, its temperature and volume starts to increase. Like you are giving heat to any system, it starts to expand, its volume starts to increase. Now, at a certain stage, when a temperature reaches at a certain level, at that point, we call it saturated liquid, and at that point what would happen, the liquid would start to change into vapor. The liquid slowly start to change into vapor. It would start into vapor. Now first, for example, 10% of the liquids change into vapor, then 20%, 30%, 40%, and finally 100% at the same temperature and pressure. Now this phenomena is known as the boiling, and this region, which is actually the changing of phase of region, is known as saturated liquid region, in which you have liquid and vapor both here. And finally, if you just go beyond that, if you just start heating beyond that, its volume would be increased and vapor would remain the same and temperature would be rise here. So actually the reason for telling this diagram is telling the stages, and also I would like to tell here, this is the region, superheated vapor region, which is actually being used in power plants, in boilers for extracting energy from the water in order to run your turbine and produce electricity. Okay, so we will talk about this when we will study the power plant diagram. Okay, some other concepts which is in your daily life is conduction, convection, and radiation. And conduction is the transfer of heat from the one side to the other side between the molecules. Like you have a cup, and if you are filling the hot cup, the hot tea in that, why you are filling that hot? Because the tea inside is transferring that energy into the walls and then into your hand. That's the transfer of energy through the molecules. And the law which we use is the Fourier law of conduction. And in this one, you can say here the K. K is known as thermal conductivity. And thermal conductivity is that how much a material can conduct heat. And we have different values for different materials. I have not included in this presentation. Like you have the most conductive material is copper, and less conductive is you have wood. So this thermal conductivity is also revolutionizing the material industry as well. Now, second one is your convection. Convection is a heat transfer, which is actually the bulk motion of the molecules. Like it's also transfer in molecules heat, but it's also the change in like its circulation of the water or the fluid, we can say. I would use the word fluid. Fluid means both you have the liquids one and the gases one. What happens in the convection is that when you heat a fluid at a certain area, like you have a heater at your home, that region would get heat up and it starts to go up. The more warm it is, the more lighter it would be. It will start to go up. When it goes up, it loses its energy and it gets cool, and cool is the heavy one, which comes down. And when it comes down, you have a heater, you get again heated it, and it goes again. And in this way, a cycle would start it, like the bulk motion of molecules would start to get from the lower side to the upper side, and this whole is known as convection. And in this phenomena, we use Newton's law of cooling. Okay, and the third one is the radiation. Radiation is a heat transfer with the help of the radiation, like you have sun radiations, and like you have these lights, which is the heat is coming from it, and you can use this heat for various purposes. Like you have microwave if you're at your home, which uses these electromagnetic waves in order to heat the food. Now, you have here the formula, which is known as Stephen-Boltzmann's constant, which is sigma A T to the power 4. And this is just a small diagram which is showing you the phenomena of convection, convection, radiation, which is being observed when you are heating some food in a pot. Like the radiation which is coming from this fire, you can feel, if you just place your hand near the fire, you can feel hot. Okay, and the second one is conduction. For example, if you have a metal handle, if the water is hot, you will start to feel your hand hot because the heat is being transferred through the molecules of the handle. The third one is a convection, which is actually going inside the food or the water which you are heating, the motion of the fluid from top to the upper. Okay, the reason for this telling you some basic concepts is that we will see these concepts and how this concept will be applicable to our industry in HVAC and the electrical industry. Now, here second law I would like to tell is actually the two statements. The first one is Kelvin statement, the second Kelvin-Planck statement, the second one is Clausius statement. Kelvin-Planck statement, it says, when you are getting energy from any source, you cannot change all the energy to work. You have to lose some energy and then convert into work. Or you can say a heat engine. A heat engine is a device which converts mechanical energy into mechanical work, cannot be 100%. The second law, Clausius statement, it says, you cannot transfer heat from low temperature to high temperature. Normally what happens, you already know that heat always transfers from high temperature to low temperature. Water always flows from high to the ground. But if you wanted to transfer the water from the low level ground to the top, you just need a pump, you just need a work. Likewise, it says if you need to transfer heat from low temperature to the high temperature, you really need a work, you really need a working device. And for your information, that working device is actually the heat pumps, which is normally the air conditioning that you are using at your home. Air conditioning is a device which is actually escaping the heat from the low to the high, escaping the heat from the low environment to the high environment. Like we have low temperature here at your home, 25, and outside is very hot, like 40 degrees centigrade. So that air conditioning is actually pushing this low heat to the high heat, taking the heat from the participants, taking the heat from the system which is inside here, the room. Okay, now these are the basics of the thermodynamics. Now we would see that how what are the applications of thermodynamics in our real world, and we will see the things in the detail. The first and the most common application is for thermodynamics is the reciprocating engine. Okay, I would say the most common application of thermodynamics is in engine, and the car engine, the locomotive's engine, and the ship's engine, and these engines are being run by the piston. If you can see in the diagram, there's a piston, okay, and this piston is actually moved by a fluid. Now, this is the best application. We talk about the water, we talk about the HVAC and everything. Now, you can see here in this system how chemical energy is actually being converted into work. That's in the previous slide, I show you are driving the car, but you never know how the car is moving. Some would say by the accelerator, some would say by the force, some would say by the petrol. Okay, fine, so it's moving by the petrol, but how it is actually moving, we will see that. It's actually a change of chemical, like you put a petrol in your car, it gets ignited, it burns, and it burns produces energy, and that energy would be enough to push a piston down, and that down piston would be again would connected with the cranks, and that crank would start to moving. Even that consists of a home generator as well. And now, just hold on, please. This is the basic overview of the engine, where we use these piston arrangement. Normally, we have a car. We have got 4 pistons. We have sometimes 3 as well. And actually, that we have valves here. When we push the pedal, we bring the air-fuel ratio in, and the air-fuel ratio is actually ignited by the spark plug that's over the engine, and that produces a burn, and that pushes the piston, and the piston starts to moving. But that all happens at high temperature, like temperatures beyond 500-600 degrees centigrade, the ignition temperature. So looking for the application of these engines, we have got 2 types of engine. One is a spark ignition engine, which has spark plugs on that. The second one is known as a CI engine, compression ignition, which is commonly known as diesel engine. In diesel, we don't have these kind of compression ignition engines. It's actually, we have a fuel injector over that. So that fuel injector actually producing the same effect that spark plugs are producing, like pushing the temperature of the fluid to the autoignition temperature, where it gets burns and the pistons start to move downward. And you know, this it's not limited to cars. If you just see the locomotive, and especially if you see the ship's engine, which is actually the pistons is the size of the home, the size of a room here. Now see the power of the thermodynamics. There is no belt system, there is no man driving the car, but only a fuel just giving a heat and pushing a piston. This is actually a meter's height. And these are the basic diagram of the Otto cycle in thermodynamics. I know you participants won't understand all this, but let me just briefly introduce it. The heat addition, which is actually being for the spark plug, for the SI engine, is actually at constant volume, and the heat rejection is at constant volume as well. These are the 4-stroke. You have heard the word 4-stroke, 4-stroke. This is actually a 4-stroke, like the intake stroke, which brings the air fuel mixture in, and the second stroke is compression one, which compresses the fluid, which increases its temperature and pressure. And the third one is the power stroke. With the help of spark plug, we produce a power. You burn the fuel, you push the piston down, and the fourth one is the exhaust stroke, in which the piston comes down and the exhaust come out of the pistons. The second one, I just talk about diesel engine, which is actually a spark ignition engine. The only difference is that the heat addition is constant pressure, because when the piston moves up, the fuel injected with the help of constant pressure. There are fuel injectors over that, and the fuel is the exhaust is exhaust at the constant volume. So these are the two basic applications of diesel cycles. And I would like to talk here, the thermodynamics also deals with the combustion analysis. Like we have combustion equations, carbon, hydrogen, fuel, and with the reaction of oxygen, and you would come to know that how much products are being produced and how much nitrogen is produced. And for that reason, you can design your system. If you know for example, the carbon dioxide, the nitrites and oxide, sulfur dioxide are harmful, you can make your system better. Like in previous cars, we don't have such kind of systems to control the exhaust, but after such a research and after such a work, the calculations, they came to they came to design some of the devices like catalytic converter, which are quite efficient to control your emission as well. Like in recently, you have the Euro emissions technology in your car. So how this thermodynamics actually changed the cars from that fuel wasting cars to now the fuel efficient car. Yeah, that's all resulted with the help of thermodynamics. So that's important part of thermodynamics, which is actually playing its role in automotive industry as well. Now, the other one is aircraft engine. Aircraft engine, which is actually based on gas turbine, which is based on Brayton cycle. I have not included its slide, but the Brayton cycle is actually based on, like, you have heat addition and heat rejection as constant pressure, not like the diesel and the Otto cycle where we have constant pressure and volume. It's actually heat addition and rejection at constant pressure, and the aircraft is actually moving with the help of action to the reaction. Like I would say, the air goes in, and from the other side you have fuel injected, and this air react with the fuel, and at the same time you have big spark plug attached to it. They produce a spark, and there is a big explosion inside the engine, and you push the gases out. When you push the gases out, and according to Newton's law, third law, action to the reaction, when gases come out, the aircraft moves forward. Okay, now this gas turbine application is not only in the aircraft, but it also in the power plants as well. And you don't saying that the power plants are only based on steam and using that water, but power plants are also based on gas turbines for moving, but they consume lots of fuel as well here. In this turbines, gas turbines, actually we have two basic components, which we have compressor, and the second one we have the turbine. When the air goes in, it compresses, and when it goes combustion chamber, its temperature pressure rises, then we produce a spark, and the pressure temperature rises again, and it goes to the exhaust. In exhaust, we have an expansion. And this thermodynamics, because temperature is quite high, 600, 700 degrees centigrade, this thermodynamics is also helping metallurgists to design their blades as well. Now, in the modern one, we have the blades which are based on nickel coated, aluminum coated blades, okay, and which have got the highest strength as well, not like that before. They work very hard for the failure as well. So look how thermodynamics is helping the industry as well. Thermodynamics is not related to heat as well. It's also helping the industry, the power sector as well, and including the metallurgies, the materials as well, to come up with the research to make a more efficient devices in the future. Now, here I would like to talk about the basic steam power plant, and then I will talk about what changes they have made. The basic power plant consists of the boiler and the turbine, the condenser, and the pump. You pump your water in boiler. Now, remember the diagram which I show you in the starting. This is just a basic one, not the advanced one. The basic, the water you add is a compressed one, which is based on normal temperature and pressure. And in the boiler, we heat the fluid to the superheated. Now, as I said earlier, we have superheated region where we have high steam content as well, which is known as enthalpy. Enthalpy means highest steam content. That means boiler is a thing in which you are giving a potential to the heat, water, in which you are giving potential. Why you are giving that potential? So that it can be used in turbine in order to turn the turbine, and turbine would be connected to the generator so that you can make an electricity. And then you bleed the steam, and with the help of condenser, you reject the heat, because Otherwise, if you don't reject the heat, it will be, the violation of second law of thermodynamics, which it says the heat engine cannot be 100% efficient. You should reject some of the content of the heat. You reject the heat, and then you can use again in the pump, and in this way the cycle started here. This is a general Rankine cycle diagram that I explained in you in the previous slide. Okay, these are all the basic application of thermodynamics that we have discussed in our previous slides. Now, I would like to tell you some of the modern trends of thermodynamics being used here. Now, let's see how thermodynamics is making modern trends here. The first application that I would like to discuss is the commonly known as heating, ventilation, and air conditioning. Actually, the people think that this field is quite different from thermodynamics, but actually it's a part of thermodynamics. Now, the basic concept which I told you about, the modes of heat transfer like conduction, convection, and radiation, all are being imposed in heating, ventilation, and air conditioning. Please don't think that air conditioning, ventilation means that you go into a shop, just bring a AC and just install it at your home and enjoy the cool air. No, it's not like that. It's actually it plays a bigger part in the large buildings. In buildings, you have thousands of workers, thousands of equipments and lightings and heating equipments running, all are producing heat. All are producing heat. So here comes the two concept. Here comes two concept, like you have sensible heat, and the second one is a latent heat. Yes, please.
Uh, After 3 minutes, we can take a break of 10 minutes, and after 10 minutes, we can again start the session with the same link of Zoom.
Sure.
You can start after 3 minutes. The session will be take a break of 10 minutes, and then we again start and continue the session with the same link. Thank you.
Sure, sure, welcome. Thank you. Okay, I would say it's not let's go show up and just be bringing the AC in. You have these high-rise building, you have thousands of workers, you have thousands of equipments, heating elements, all adding heat to it. Now, I was talking about the latent heat and the sensible heat. You can just note it down. The sensible heat is actually the change in temperature only. And the latent heat is actually the change in the state as well. Like in heating, ventilation, you get the heat, and heat it's only increase the temperature, that is sensible heat. But if you are using some water, like you are making a tea and you are breathing, you are actually adding some moisture content to the atmosphere, and in this way you are increasing the latent heat. Okay, now what we do in this HVAC system, we actually properly calculate all the loadings here, like how much heat a human being is producing. It's being said the human produces around 100 watts of bulb, and how much heating equipments are there, all we calculated. Plus, apart from that, we also see how a building is oriented in a city. If a building is oriented in such a city which is quite hot, and it's shaping the sun rising and it's shaping the sunset, how much wind it is and how much the weather is affecting, and how much sun radiation intensity is. Okay, now here comes the radiation concept as well, and how much windy is the city is, because once the winds would blow, the outside area of the building would be cold, and then it would reduce the heat transfer. If the atmosphere quite hot, then some of the heat would be transferred inside. Okay, some of the heat will transfer inside, so you have to design efficient material for that. And once the heat comes in, you can say outside load, then your cooling load would be increased. So these are all the factors that we discuss in heating, ventilation, air conditioning, and in that diagram you can see some of the components which is being shown here, like how the solar load, how the person is giving the heating, and even infiltration, the small gaps between the windows and doors also increases the moisture content as well, and also increases the temperature of these systems. Now, in order to cope this heating, ventilation, and air conditioning, the thermodynamics researchers have developed software which is known as Energy Plus, and lots of software in the market here. So how this software being used in this heating, ventilation, air conditioning, and the proper designing of the system. Now, you can see here again the material comes in. The more the heat comes in, the more efficient system you want to make, the more building materials, the more efficient building materials you will go for the research here. Now, this actually, I'm talking about the thermodynamics, supporting the construction industry as well. Yeah. Okay, and I think the session is